Assignment class was 10. Okay, we have 3 problems. The first problem, estimate the size of the reservoir for the money data in below table. Assume that required downstream is 0.13 cubic meter per second. Constant surface is 6.07 square kilometer. Runoff coefficient is 0.4. Okay, this gives you the inflow. This is inflow, but the unit is cubic meter per second already. So when we have inflow to the reservoir, we don't need to use the runoff coefficient because this should be convert from rainfall to runoff. But now we already have runoff to the reservoir, so we don't need to use 0.4 anymore. And next, this water requirement or water consumption. It's already in the million cubic meter, but for evaporation, so we have to convert to millimeter to the volume. This is rain. So we have to convert to cubic meter as well. So we can draw a new table for calculation in the bottom of this page. We have 2 unit inflow from the cubic meter per second and million cubic meter. Consumption. Okay, we can draw the table. Let's say the first one is January and the second one is Feb 28th day. So we can write given the inflow. I forgot to. Okay, so we put the next we have to find what is the volume of the inflow from convert from cubic meter per second to cubic meter per month. And for the downstream, we have to convert from 0.135 cubic meter per second times the number of seconds in a month. We got like so this should be 0.362. Okay, so from how to calculate the downstream volume. Okay, and to check the balance between inflow and outflow, if the first month it should be positive, is about 6.637. Okay, you can do the rest of the months and check which month is negative balance, so we can sum all negative to get the reservoir storage or reservoir capacity for this problem. Okay, the next second two, problem 2. From the mass curve, estimate the size of the reservoir if required water consumption is 2 million cubic meter. So this one you have to find the demand slope first. Okay, you have to develop the slope. Okay, so the way you have to develop, you have to find the scale. So you can measure from the picture. For example, you measure that it's about 2.8 centimeter, and from this unit it should be 1,000 million. Okay, you can convert from to find if the 2,000 is how many cent, and you can make the slope. Okay, and for example you can make slope like this. Assume. And next we can draw the slope. And measure this length, for example, to find the storage, the reservoir size, the reservoir storage. Okay. And for the problem 3 is opposite way. Given the storage is 10 million, so we have to convert back to S from if you measure that is about, it depends on your measure. You have to measure by yourself, but because sometimes the scale is expand or squeeze. If it's equal to this, you can measure. You can find if the 10 million is how many cent. Okay, and this one we can is S, so we can draw S is near. And find the two slope. Okay, and you can find compare the two slope and to find which one is smaller should be the available water. Okay, you can find by yourself. what is the available water from this reservoir if the size reservoir is fixed to 10 million cubic meter.